Next, beware of confounding variables. Those are variables that can interact. These are often variables that are not intended to be part of the study that can make it difficult to interpret your results. Guideline 6 is we want to consider the setting and the wording surveys, right? You have to be really careful with wording, right? Many words have positive or negative connotations that can influence our opinions. So even when a survey is conducted with proper sampling and clearly defined terms and questions, you have to watch for problems in the setting or wording that might produce inaccurate or dishonest responses or introduce bias. Dishonest responses are particularly likely when the survey concerns sensitive subjects, right? So if we're surveying teenagers about sexual activity or drug use, they're probably not telling us 100% of the truth. So the Republican National Committee commissioned a poll to find out whether Americans supported their proposed tax cuts. Asked, do you favor a tax cut? A large majority of respondents answered yes. Should we conclude that Americans supported the proposal? Why or why not? So first off, of course nobody wants to pay more taxes, right? Of course everybody's gonna be like, yeah, I want to favor a tax cut. But it doesn't say what it's cutting. Like, would you favor a tax cut if we cut funding to education, transportation, right? Would that really be fair? No. Another thing I said is, in one study I said was, I was asking, like, how did COVID-19 affect your day? Making it seem like it did affect your day. I had to change that to did, right? Did COVID-19 affect your day? Because it could have not if you already worked from home, right? So how could make you like think you have to tell me that it changed in some way, even if it didn't. So that's another example of being careful with your wording. You need to check that the results are presented fairly. So even when a statistical survey is done well, it can contain misleading graphics, we're going to talk about those, or concluding statements that aren't true. Next, you want to stand back and consider the conclusions. Ask yourself these questions. Did the study actually achieve its goals? If it didn't, did it say it didn't? That's okay too, right? Not all studies have to achieve their goals. Do the conclusions make sense? Can we rule out alternative explanations for our results? And if the conclusions make sense, do they have any practical significance, right? That's how we get a lot of silly studies out there, right? Like that a glass of wine will like help your heart. Oh no, chocolate will. Oh no, eggs will. In order to like maintain a job of research, you have to get your research published. So sometimes there are some silly studies out there. So here are the 8 guidelines for critically evaluating a statistical study. So what was its goal? What type of study was it? What's the source? Look for bias. Make sure that you can actually define the variable they're looking for. Beware of confounding variables that can invalidate results. Make sure the setting is appropriate and the wording is appropriate as to not introduce bias, right? That's 99% of this is don't introduce bias. Check that the results are presented fairly, i.e. without bias or without misrepresentation and graphical representations. We'll talk about that in chapter 2. Next, stand back and consider the conclusions. Does this study have significance? So, end of chapter quick quiz. The collection of all cars registered in the United States is an example of a population. Is that true or false? Well, that's true, right? If we were studying all cars in the United States or all registered cars, that could be a population. If we were studying all cars, I'm now realizing the wording of this is poor. If we were studying all cars in the United States, not all of them are registered. So then it would be false. But I was thinking we were just studying all registered cars in the United States. Selecting every 5th name on a list results in a simple random sample. That's actually false. That is a systematic sample. The average age of people who respond to a survey is a parameter. Well, that's also false. That would be a statistic, right? When you have a sample, the results give us a statistic. eye color is an example of ordinal data. We didn't talk about that yet. So excitement to come up in chapter 2.